Imagine, 1.5 billion kilometers from Earth, there is an ice ball the size of Arizona. Beneath its crust lies an ocean older than humanity, and in this ocean are molecules that make up life, and perhaps something else. On the 28th of August, 1789, British astronomer William Herschel pointed his new telescope, the largest in the world at the time, at Saturn. Among the faint dots barely visible in the glow of the rings, he noticed something, a tiny spark. Herschel could not have known that he'd just discovered one of the most mysterious objects in the solar system. He named it Enceladus, after the giant from Greek mythology buried under Mount Etna. The title turned out to be prophetic. Something was indeed hidden beneath the surface of this world. For nearly 2 centuries, Enceladus remained just a dot in telescopes, too small, too distant, too close to the dazzling glow of Saturn and its rings to see any details. Astronomers knew 3 things about it. It exists, it orbits Saturn, and it is incredibly bright. Brighter than any other body in the solar system, as if someone had covered it with fresh snow. The first hints that Enceladus was more than just a dead ice rock appeared in 1980. The Voyager probes flew past Saturn and transmitted blurry but intriguing images back to Earth. There were almost no craters on Enceladus's surface. For a geologist, this is like finding a corpse with no signs of aging. Something is constantly renewing the surface, but what exactly? There was no answer. The Voyagers rushed onward to the edges of the solar system, leaving the mystery unsolved. Another 17 years passed. On 15th October 1997, the Titan rocket launched from Cape Canaveral. On board was a spacecraft that would change everything we knew about Saturn and its moons. It was named Cassini, after the Italian astronomer who discovered the gap in Saturn's rings. 7 years and 3.5 billion kilometers. That was the journey awaiting the probe before it reached its destination. On the 30th of June, 2004, Cassini entered Saturn's orbit. The hunt began. The first flybys past Enceladus seemed routine. Just another satellite. Just another icy moon in the entourage of a gas giant. Scientists expected to see a dead world, a geological corpse, frozen billions of years ago. But Enceladus refused to play by the rules. In 2005, Cassini's cameras captured something impossible. Jets were shooting into space above the moon's south pole. Giant fountains of ice particles, water vapor, and something else. Something that the instruments could not yet identify. The material burst out of cracks in the icy crust at a speed of 300 kilometers per hour and flew into space, forming one of Saturn's rings, the dim, almost invisible E-ring. Enceladus was not dead. He was breathing. These cracks, 4 parallel faults, each about 135 kilometers long, were dubbed tiger stripes by scientists. From them, like wounds, flowed the blood of another world, and this blood carried information. What powers these geysers? Where does the energy come from on this tiny satellite, which according to all the laws of physics should have frozen solid billions of years ago? The answer turned out to be both simple and astonishing. An ocean lay hidden beneath Enceladus's icy crust, a real, liquid, salty ocean. Global, stretching from pole to pole. The thickness of the ice shell above it ranged from 16 to 30 kilometers, and the ocean itself. Its depth in some places could reach tens of kilometers. Saturn's gravity was what kept this world from dying. Tidal forces constantly compressed and stretched Enceladus's core, generating friction. Friction generated heat, and heat prevented the water from freezing. But that was only the beginning, because water is not life. Life requires something more, and Cassini found it. To understand why the discoveries on Enceladus shook the scientific world, one must first understand what life is from a chemical perspective. All life on Earth, from bacteria in boiling springs to blue whales, is built from the same set of elements. The 6 building blocks of the universe are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Scientists refer to them by the acronym SETNOPS. Without any one of these elements, life as we know it would be impossible. But elements are just the alphabet. You also need words, complex organic molecules, amino acids, which make up proteins, lipids, which form cell membranes, nucleotides, the basis of the genetic code, and most importantly, you need energy to power all this machinery. On Earth, Most ecosystems are powered by the sun, but there are exceptions. In 2000, oceanographers discovered a place in the Atlantic Ocean at a depth of 800 meters, which they called the Lost City. It is a hydrothermal field where alkaline springs with temperatures of up to 90 degrees Celsius gush from the seabed. White carbonate towers as tall as an 18-story building. The tallest of them, Poseidon, rises 60 meters. The Lost City is not like black smokers, those volcanic vents that spew superheated water saturated with metals and sulfur. A different process takes place here. It is called serpentinization. Seawater seeps through the mantle rocks, reacts chemically with them, and produces hydrogen, methane, and heat. No volcanoes, no magma, no sunlight, and in this darkness, in this alkaline environment with a pH higher than 9, almost like household bleach, life thrives. Microorganisms that feed on hydrogen and methane, an ecosystem that has existed for over 120,000 years, completely cut off from solar energy. The Lost City changed scientists' ideas about where life could originate. Some researchers believed that it was in places like this, rather than in warm ponds on the surface, that the first living cells appeared 4 billion years ago. Now imagine the same thing, but on Saturn's moon. Cassini data showed that serpentinization occurs at the bottom of Enceladus's ocean. Hot water interacts with the rocky core, producing hydrogen and methane. The temperature in the contact zones is above 90 degrees. The environment is alkaline, with a pH of 8 to 12. Instruments have detected silicon dioxide nanoparticles, which can only form at temperatures above 90 degrees in the presence of water and rock. Enceladus is the Lost City of space, only millions of times bigger. By 2017, scientists had confirmed the presence of 5 of the 6 KNOPS elements in Enceladus's emissions: carbon, hydrogen, nitrogen, oxygen, and, sensationally, phosphorus. Sulfur has not yet been detected directly, but researchers are confident that it is there. However, elements are only half the story. The question is whether they combine to form complex molecules, and here, the story takes an unexpected turn. On the 9th of October 2008, Cassini performed the most daring maneuver of its entire mission. The spacecraft plunged straight into Enceladus's plume. It didn't just fly past, it shot right through it at an altitude of only 25 kilometers above the surface. Its speed was 17.7 kilometers per second. That's more than 60,000 kilometers per hour. At that speed, a particle the size of a grain of sand could pierce the probe's hull. But the risk paid off. A device called the Cosmic Dust Analyzer was on board Cassini. Its task was to capture microscopic particles and determine their chemical composition. The principle is simple. An ice grain flies into the detector, instantly evaporates on impact, and a mass spectrometer analyses the resulting cloud of ions. The problem is that water molecules are sticky. At low collision speeds, they clump together into clusters and mask everything else. It's like trying to see grains of sand at the bottom of a glass of milk. The liquid gets in the way. But at a speed of 18 kilometers per second, everything changes. The impact is so strong that the ice particles literally explode, scattering into their elementary components. The water does not have time to regroup, and then everything else becomes visible. The data from this flight was stored in archives for almost 17 years. No one knew what treasure lay there. In October 2025, an international team of scientists led by Nozer Cavaggi from the Free University of Berlin published the results of a new analysis. They applied modern computer modelling techniques to old data, what researchers call data archaeology, and the archive spoke. In the ice grains ejected from Enceladus's interior, just minutes before Cassini swept through the plume, molecules were discovered that no one expected to find. Ethers, complex ethers, alkenes, aliphatic compounds, acetonitrile and pyridine, nitrogen-containing organic substances have been preliminarily identified. It's not just chemistry, it's the building blocks of life. Esters are part of lipids, the very molecules that make up cell membranes. Without membranes, there are no cells. Without cells, there is no life. The amines discovered are precursors to amino acids, the building blocks of proteins. But the main thing is something else. The main thing is the age of the particles. Previously, scientists analysed material from Saturn's E-ring. These particles could have been floating around in space for months or years, exposed to radiation, cosmic rays and solar wind. Their chemical composition could have changed. Skeptics said, maybe these organic molecules are the result of cosmic weathering? Maybe they formed after the ejection. The year 2008 closed this issue once and for all. The particles captured by Cassini were fresh. They were only a few minutes old. They had not yet been exposed to any external influences. Their chemistry is the pure chemistry of Enceladus's ocean. And in this ocean, complex organic molecules are synthesized, not brought by meteorites, not created by cosmic rays, born in the depths of the satellite itself, in areas where hot water meets rock. Just as it happens in the lost city at the bottom of the Atlantic. Nazaire Khawaja, lead author of the study, put it this way: these new organic compounds may support chemical networks and pathways that could potentially lead to biologically significant molecules. Translation into human language: Enceladus has everything necessary for life to arise: water, energy, chemical elements, complex organic compounds, a stable environment that may have existed for billions of years. The question is no longer whether there could be life there. The question is why there might not be. On the 15th of September 2017, at 4:55 Pacific Time, the last dot disappeared from the screens at NASA's Jet Propulsion Laboratory. Cassini was dead. 83 minutes earlier, exactly the time it takes for a radio signal to travel from Saturn to Earth, the spacecraft entered the atmosphere of the gas giant. 20 years in space, 13 years in Saturn's orbit, 2 million commands executed, 453,000 images transmitted to Earth, and now, the end. But it wasn't an accident. It was murder. Premeditated, carefully planned, necessary. Fuel was running out. Without fuel, it was impossible to correct the orbit. Without control over the orbit, the spacecraft would sooner or later crash into one of Saturn's moons. And if that moon turned out to be Enceladus or Titan, worlds where life could exist, the consequences would be catastrophic. Earth microbes remained on board Cassini. Despite all the sterilization procedures, despite 20 years in a vacuum and radiation, some bacteria could have survived. The spores of some microorganisms can withstand almost anything. If they had entered Enceladus's ocean, they could have contaminated it. They could have destroyed what we were looking for before we even found it. Or even worse, they could have created a false positive result. We would have found life, but it would have been our own life brought from Earth. Therefore, Cassini had to die. Not on Enceladus, not on Titan, in Saturn's atmosphere, where no biology is possible in principle. The final months of the mission were dubbed the grand finale, 22 orbits between the planet and its rings, where no spacecraft had ever flown before. Each orbit carried the risk of collision with ring particles. Each orbit yielded new data on gravity, magnetic fields, and atmospheric composition. In its final seconds falling into Saturn's clouds, Cassini continued to transmit information. Its engines were running at full power, trying to keep the antenna pointed towards Earth. The atmosphere was getting denser and denser. The spacecraft began to tumble. Communication was lost. Somewhere out there in the yellow-brown clouds, Cassini flashed like a meteor. 20 years of work turned into a brief flash in the sky of a foreign world. But the data remained, and 8 years after the spacecraft's demise, this data continues to change our understanding of the universe. The discovery in October 2025 is not the end of the story. It is a new chapter. Scientists continue to dig up the Cassini archives, using analysis methods that did not exist in 2008. Who knows what else is hidden there? But one thing is already clear. Enceladus is not just an interesting object to study. It is a priority target, a place where humanity must return, and humanity will return. In November 2025, the European Space Agency announced its plans. Enceladus has been chosen as the main target for the next major mission, which will replace Juno, Lisa, and Athena. The launch is scheduled for the early 2040s. 2 Ariane-6 rockets will carry the spacecraft components into orbit. They will dock in space, a technology that still needs to be perfected. The journey to Saturn will take about 10 years. Arrival is tentatively scheduled for 2052 or 2054, when summer will arrive at Enceladus's south pole and the geysers will be at their most powerful. But it won't be just a flyby, not just an orbital vehicle. For the first time in history, a landing module will descend onto the surface of Enceladus. It will land in the area of the Tiger Stripes, where ocean water, frozen into ice crystals, falls back to the surface like snow. This snow is a direct sample from the subglacial ocean. There is no need to drill through 30 kilometers of ice. The ocean itself ejects its contents onto the surface. The new generation of instruments is so sensitive that in theory, it can detect a single bacterial cell in an ice grain. The mission will not just search for conditions for life, it will search for life itself, or traces of it, or its predecessors. One of the authors of the 2025 study, Nozer Kawaja, said something that may well go down in history textbooks. Even if we don't find life on Enceladus, it will still be a huge discovery, because then the question will arise, why is there no life where all the ideal conditions for it exist? Think about it. We found a world with liquid water, with a source of energy, with the right chemistry, with complex organic molecules, with a stable environment that has existed for billions of years. We found everything necessary for life. If there is no life there, it means that we fundamentally misunderstand something about the phenomenon of life itself. It means that our theories about its origin are wrong. It means that we are an incredible, statistically impossible accident in the universe. What if there is life there? Then everything changes. Then life is not a coincidence, but a pattern. Then, wherever there is water, energy and chemistry, sooner or later, a spark will ignite. Then the universe is not dead. It is teeming with life that we simply have not yet learned to see. 1.5 billion kilometers from Earth, an icy sphere lost in Saturn's shadow, an ocean hidden beneath kilometers of ice, geysers shooting into the cosmic darkness, and somewhere out there, in this darkness, perhaps floats the answer to humanity's most important question. Are we alone or not? In 30 years, we may find out. If you have enough patience, if you have enough willpower, if you have enough courage to accept the answer, whatever it may be,